Okay, a couple minutes after the hour, so I think it's a good time to get started. So again, welcome everyone. Hope everyone's having a lovely morning or afternoon, wherever you are. My name is Bijan Yakon. I'm a technical account manager on Altair's aerospace team. Soon I will be changing all of this formatting and my title to my new Siemens title. As I'm sure most of you are aware of by now, we have been acquired by Siemens, and so we'll be integrating more closely within Siemens coming into the next year, which I'm really excited about. But yeah, today what I wanted to talk to you guys about was concept modeling, which is a ribbon within HyperMesh. But mostly I wanted to keep the conversation within the context of GFEM modeling in general. So, first, briefly before we jump into the process in HyperMesh, let's discuss a little bit what is GFEM modeling. What is this used for? So, yeah, what is GFEM? So GFEM, which stands for Global Finite Element Model, or sometimes referred to as a generalized finite element model, or sometimes referred to as an external loads model as well. And really what it is a simplified sort of reduced order model of the overall aircraft, right? Where instead of getting a super detailed representation of all of the features within the aircraft, you instead represent a more generalized version of the aircraft through usually through quad dominated shell meshes to represent your panels and your skins, and then using beam or 1D idealizations of your beams, stringers and frames and things of that sort. Really just to get a more reduced order model, to get a faster running model early on in the loads process of the aircraft. So this is just an example here of like a nose portion of an aircraft fuselage GFEM model, right, where you have basically all these panels representing, in this case, just one single element separated by these stringers and frames as 1D elements, I should say. Okay. And so where does GFEM fit within the airframe loads process? Let's take a quick look at that. So generally it sits right after the loads model is generated, right? So you would go through all these different loading conditions that the aircraft might undergo within its normal operating conditions or extreme operating conditions, right? So loading conditions like thrust, gust, drag force, all these different things are analyzed and determines to come up with the critical design driving load cases. Okay. So then that's done within the loads model and then sent to the GFEM model to apply as boundary conditions onto our global mesh. Okay. And then from there, you determine your internal loads that can then get mapped onto a more detailed finite element model referred to as the DFEM model. Okay. And then continuing forward, so kind of how this transition works a little bit. Like I mentioned, kind of we would generate that loads model, apply it to our GFEM, and then you would use free body diagrams to generate your internal forces that you can then apply onto your DFEM or your internal loads model. Okay. And so we are going to be demoing the free body diagram workflow within HyperMesh actually in our next session in 2 weeks. So, if you guys want a nice segue into how to generate those internal loads from the free body diagrams, stay tuned for our demo in exactly 2 weeks from today. Okay, and then yeah, you got some examples of your global finite element model compared to a much more detailed DFEM model, right, where you can see you got many more elements. Okay, so yeah, so again, what I wanted to or go through here today with you guys was the concept ribbon within HyperMesh that you can use to generate these DFEM models from just a series of lines that you bring in. Okay, so let me open HyperMesh here. I like to do my demos in the latest and greatest released version of HyperMesh, so I'll be doing this in 25.1. Let me drag and drop this model here. Then so I have this lines model that I'm going to load up here. And so generally, typically, this would be your starting point for developing a GFEM model, right? Some series of lines, something like this. We do recommend using some native CAD software to generate, your OML lines, your outer mold lines. However, you do have, just FYI, you do have some basic, sketching and line creation options within HyperMesh if you're just maybe trying to generate something simple and quick. So just quick FYI, but yeah, generally we recommend, using, CATIA, NX, whatever it is that you're using for CAD. Okay. So if we come over here, your concept ribbon may not show up by default. If that's the case, just come right click over here in the white space to the right of the ribbons and just turn on concept ribbon here. So that's what we'll be using. Some of these I think are more relevant for like automotive kind of generalized models, like the doubler and the bulkhead creation tools. So I'm going to skip over those tools and mostly spend time on the stiffened panel tool, as this is what you can use to create all of the panels, stringers, and frames for the fuselage. Okay. And I'll touch just briefly on creating beads if I have some time, as I think that can maybe be useful if you want to just like add in some beads somewhere specifically, and anywhere on your skins. Okay, so yeah, let's go ahead and start. We'll open up our stiffened panel, and going into our options over here, you can determine, whether you want to remove the geometry, like the lines that you're going to use to create this GFEM. I'm going to leave them, so I'm going to turn that off. And you can choose how each of the like panels and stringers and all of that get organized, whether you want them into just a single current component or create new components or new part assemblies for each of the panels and stringers and frames that it creates. So in this case, it would create a single new component for each individual panel, stringer, and frame. So that's what I'm saying here. Alrighty, and so then we can go through and pick the longitudinal lines defining our OML. In this case, just a fuselage, a generalized fuselage. So maybe I'll just do like a side view like this, and just do like a box selection like so. Looking through, I don't think I accidentally selected any lateral lines, so we should be good there. So I'm going to go ahead and now select my lateral lines. So these are going to be, sort of I don't know a better way to describe these lines than lateral lines, but, just the ones kind of going across the fuselage. So I'm just going to do, again, a box selection here. Okay. And I'll just do those lines. I won't bother with the full fuselage here. Okay, and then from here, we can define within this guide bar, we can define our properties for our shells as well. So our P shells we can define here. That is optional. You can assign your P shells after the fact. And if you're using just a constant thickness for all of your shells, for all of your skins, that might be advantageous. But just to show you guys sort of how you can create this just from within the guide bar, if you right click, oh, excuse me, I need to be within the panel. So make sure you got the panel selected. Then we're going to right click, and it'll give us our option to create a property, again, from within our guide bar here. So I'm going to create property. We'll name this P shell. All right, it's already got the right card image set. I could assign my material if I want, but I don't think I have one defined yet. And I'll define some thickness, maybe 10. Okay, and I could bother with the offsets if I wanted to, but maybe let's not bother with that for now. So we'll close that out, and then it'll automatically, as denoted by the bracket here, it'll automatically select that property I just created. Okay, and so when you do it this way, it'll create a distinct property for each panel that it creates. So we'll see that whenever I create the panels here in a second. Okay, and so yeah, then once I've defined my longitudinal and lateral lines, and the defining, again, this is optional, but then defining the property, I can then go and find panels. HyperMesh will then go through and generate out the panels between each of those lines. So we'll do find panels. We'll zoom out, we'll see how it looked. And so a couple things to note here. Let me see what to start with first. Let me start with the origin point first. So basically how this works, and I realize I should have selected that line as well. But anyway, so yeah, so what this is showing us is a few things. One, it's showing us our origin point and numbering direction. So this is all just for ID management of the elements that it creates. So generally it would start, from 1 and sort of increase up by rows and then would jump over to the next row. So basically what we're saying here is this is our origin point where we're going to start our ID numbering, and then we're going to increase that numbering along this axis here. So if you want to change the origin point to the renumbering direction, you can do that. So I could make this the origin point. And you want to select the fixed point, which is the circular one, not the X one. So select the fixed point. It'll auto adjust the renumber direction. But if you want to change it to something else, you can just make sure you have that selector active and then select another point. And then it changes that renumbering direction. All right. So a few other things, you probably noticed this little arrow. So this is defining the normal direction for the shells. Yeah. And so this will come into effect whenever we're orienting and offsetting our 1D elements relative to our shells. So in this case, I would want to offset my 1D elements sort of inside through my fuselage. So I'm going to just flip that direction just with this plus minus. So I'll just make it a little easier for me to offset my beams inward based on the thickness of my panels that are representing my thickness, my skin thickness. Okay, and then a few other things. So by default, as you can see, it'll just generate, and what we're looking at are surfaces. Okay, so it hasn't generated any elements yet, but it has generated geometric surfaces that will remain there. So it's basically just giving us our preview of our panels that it would generate. And by default, like I mentioned earlier, it would generate one panel in between each stringer and in between each frame. And so you can change that with these little dots here. Switch to manipulate selectors. So if we click that, it'll give you a element density layout for just one of the panels close to the origin point. So I changed the origin point to here, so it's giving us our edge density changing here. Okay, and so whatever edge densities I set here will get propagated to all the rest of the panels. Okay, so basically this is just saying how many layers of quads I want, along this edge, and then how many layers of quads I want along that edge. And so then that would, of course, also affect the number of beams along that edge as well. Okay. So it's defined, and you want to make sure you remember this, because this kind of burned me when I was practicing this. You define the edge densities and the beams on the frames and the stringers independently of each other. So what do I mean by that? Let's take a look. Let's say I want 3 rows of quads and beams along these edges of my panels. So I'm going to click on that edge, bloop, bloop, go to 3, and then this little option here gives us our option to define our beams, right? So if we click on that, kind of same scenario, right? If you right click, you can create a property. And so here we can create our P beams. So, oops, come on. P beam. Change our card image to P beam. And I can create my beam section from within this dialog as well. So I can right click, create. I'm going to create a rod section. That's already the preset, but of course, if you wanted to create T stringers, hat stringers, we got all those presets here. So I'll just lastly define the radius for that rod. So if you're ever curious what any of the dimensions mean, you can just hover your cursor and it'll give you a little preview. So yeah, maybe let's just say I'll go with just 10. like 10 inches for that radius. And I think that's all that I need to define here. Beam, rod section, yep. So we should be good here with the property. Once we close that out, you'll see, so this is another thing to note here. When you're defining the beam properties, it won't automatically select the beam property you just created like it did with the P shells for the panels. So you just want to make sure you take that extra step to go in to the lists, your properties, and grab that P beam. So now I see the bracket with the ID, right, of that P beam. So now I know that's selected. So if I click that check mark, that only defines the edge density and 1D element type for those sort of longitudinal stringers, right? So then if I wanted to do the same for the latitudinal frames, you have to make sure you do that process again. So click switch to manipulators, select that edge, and then do the same thing. So maybe I just want 2 rows of quads and beams along that edge. And now I go back into the property loop and grab that P-beam. So in this case, right, I'm just using the same P-beam property I created for the stringers. But right, if you wanted to, you could create a separate cross section, for example, for your lateral beams. Okay, and then with all of that set, if I remember right, I wouldn't recommend hitting this play button, but hitting this play button, assuming I remember correctly. But we'll see. And then if not, I can show you guys how you can, just like add in 1D beams later if that doesn't work. So we'll generate our elements here. Okay. Let's get out of here. So you can see it creates our beams. Okay, I think I messed up. I need to go back and adjust that density over there. You can see it created our double layers here, at least. And then if we exit out of there, turn on our 1D and quad visualization. We can see, oh, and one thing I've noticed, so we can already see, and I did that kind of quickly, but if you come down here and turn on your element handle visualization, you can turn on a detailed or 3D representation of your beam sections and your shell thicknesses, respectively. So that's what I turned on. So we can see those rods that I created. And this is something I've noticed, at least in this version, is sometimes it won't immediately visualize the shell thicknesses, but if you just go into your P shell, go down to your thickness and just hit enter, there you go. It turns on that visualization. So yeah, just a weird little thing with this version. But so now I can see my visualization of my beams and my shell thicknesses. So then, as you can see, it won't automatically orient the shells or offset the beams based on the shell thicknesses. So what you can do there is come over to 1D, edit beam, and adjust those offsets. So I'll just select all of my beam elements to do all of that at once. So sorry, I'm going kind of quickly here. So I'm bringing up advanced selection, loop, where I can select by configuration, by element configuration, and then grab all of my beams. And I want to orient these offset these based on the shell thicknesses. So I'm going to choose this left option here, stiffener on shell elements. And then really any of these 2 options would work. So if we do something like that, there we go. We can just right click, check, and now we're good. And so just like that, we got our nice GFEM model with our panels. I forget, did it actually, okay, it actually did get the 3-row separation here. My mistake. So yeah, everything worked out okay. So I got the 3 rows here, 2 rows here, beams properly created on each row. And yeah, now we have our GFEM model. So if we take a look at how it organizes all of our components and properties, so you see it names based on the, and I should have mentioned this, but it's based on the prefix that you can define within that tool. Set. So you can change these prefixes if you want. Like you could do, maybe skin here, spar here, rib here, whatever you prefer for your naming conventions. But you see, yeah, it creates sort of one component for each panel and each beam it creates, which you can right click and review. You got the panels, your stringers, frames were up at the top. Okay. And a few other things. Oh yeah, I wanted to also touch on if you want to check the element IDs. So we can just switch our selector to elements, grab all of our elements, right click, more, show IDs. Should have been incrementing, I think, from up here somewhere. But if you aren't satisfied with the ID naming convention, you can always refer back to the assembly ribbon and the renumbering tools here. So there is a spatial renumbering that I think could be helpful. You could do like a spatial renumbering or a rectangular grid renumbering. So, something like this. So yeah, so you can adjust the spatial renumbering or adjust the numbering of your elements using spatial renumbering or just basic renumbering if you'd like. Okay, and then I think I also want to show, and let me clear your IDs. Exit this out. I got a few more minutes here. So yeah, I'm going to be wrapping up here. If you guys have any questions, drop them in the chat. But maybe just quickly, I'll show one more thing, and I'll show the beads. I keep missing. There we go, concept driven. So one thing about the beads is since it's based on altering the shell mesh or the panel meshes, you have to disassociate the surfaces that the stiffened panel tool creates from those shell elements. So there's you can go to 2D, edit elements, associate, and then disassociate. So you can do it that way, but in this case, I'm just going to delete the surfaces since I don't need them. That's all my surfaces. So remember, it created those like kind of as a preview, but I don't really need them anymore, so I'll delete them. No, I do not want to delete associated elements. Okay, so once you remove that associativity between the elements and the surfaces, we can go back, create a bead. And you can use a pre-drawn line, but in this case, I'll just draw a bead line like maybe something like that point to that point. So I just left-clicked release and left-clicked release. I didn't do like a hold or anything like that. And then it's pretty self-explanatory, actually, pretty easy to pick up. So you can just adjust the width of the top here. Maybe I want to go 20. Just keep tabbing to going down to each selector, right? So maybe I want my bottom width to be 45. My height, let's see what 40 looks like. Maybe that's too much, maybe 30. Yeah, something like that. And then, you can adjust the lengths at the ends as well. And then, of course, you can just change the direction and move it around. And then this will, as you add the bead and create the beads, it'll adjust the shell mesh that gets connected to it. So there we go. You see it splits up that panel, makes sure that it's all connected to that bead. And so it's creating quad elements here, C quads. And I am still visualizing the thickness, so that's why it looks like they're 3D elements. Okay. Let's see. Did I have anything else I wanted to cover? I don't believe I did. I showed the model organization. Um, and so, yeah, that just about covers what I wanted to show for kind of what are GFEM models and then how to generate them. So again, like I said earlier, we're going to be having a demo over generating internal loads with the free body diagram tools. Free body diagram tools in our next session in 2 weeks. So hopefully that'll be a nice segue for you guys. Hopefully that'll be helpful for some of y'all who are interested in this topic as well. So we hope to see some of you guys then. But before I end today's session, does anyone have any questions? Anything else I can help address? Yep, wonderful. Glad to help. Did it mesh that bead as shells? Yes, it did. Yeah. So it created C quads here. So if I hover my cursor over that, you can see like kind of the preview for the element type, and then it's C quads it's generating. Oh, and it can sometimes generate tries as well, but it is a shell mesh. Where can I find all the pre-recorded sessions? That's a good question. We're uploading all of these onto our YouTube channel. We have a playlist on our YouTube channel. Let me grab that and put it in the chat real quick here. Boom, playlists. Here we go. So I'm putting it in the chat, but if you lose track of it, you can just search Altair Aerospace Coffee Breaks 2025 on YouTube, and it'll come up. Okay. Any way to have that just be 1D elements? In that case, I think I would take a different approach. I would probably use the line mesh in that scenario to generate those. Like if you wanted the bead to be a one, like a 1D beam here, I think the process I would do is just draw a line, project or split that line onto the elements or themselves or onto the surface, and then line mesh that line. That's how I would accomplish that one. But the beads tool under the concept ribbon at least is just for creating shells. Yeah. But yeah, Matt, we have a 1D video in the playlist that I sent. I don't think we have that exact scenario of like projecting a line and onto a shell mesh and creating a beam from that, but we do at least show creating like stiffener beams on an existing shell mesh, for example. But hopefully that helps. Yeah, good questions, guys. Does anyone else have any other questions? All right, wonderful. Well, I'm gonna drop the link to this series in the chat. I'm sure you guys already have this, but just to give it to you guys again, if you want to register for any of the upcoming sessions, and we also have a survey on there. So if there's a topic you want to see that we haven't scheduled or covered yet, feel free to recommend it to us, and feel free to let us know how we're doing with the series. If it's helpful to you or not. But if we're good on questions for today, then I'll go ahead and let you guys go. But as always, it's really good getting to chat with you guys, help you guys out with some of these things, and I hope it's helpful for you guys. So hope everyone has a lovely rest of your day.